students, welcome to the maths class. Students, we have started with the topic limits, continuity and differentiability. And we have completed with the two topics of this chapter, that is limit and continuity. Today we are going to start with the differentiability. So, in the previous lecture, we have completed the continuity of a function at a point. Then we have discussed continuity of a function on an interval. So, today we are going to start with the differentiability of a function at a point. First of all, let's discuss limits. Now students, you have seen that in limits, we always calculate two limits, that is left hand limit and right hand limit. And if both the limits are equal, that is left hand limit is equal to right hand limit, only then limit exists, otherwise limit does not exist. Limit exists. Now, same concept is there in the differentiability also. Differentiability means we have to check the function is differentiable or not at a given point. Now, suppose that here point is C. At point C, we will again check is the function is left hand derivative. Then we will check is the function is right hand derivative. If both their left hand derivative and left hand derivative having same value, only then we can say that function is differentiable at that point. Here point is C and C can take any value, that is 2, 3, 4, any value must be there. So first see the formula for finding the left hand derivative and right hand derivative. Left hand derivative is limit h approaches to 0 f of c minus h. C is the point at which we have to check the differentiability. So minus fc upon minus h. That is a left hand derivative, we will put the value minus h. In right hand derivative, limit h approaches to 0 f of c plus h minus fc upon h. Here h is positive. So these are the two formulas that we are going to use for the left hand derivative and right hand derivative. Let's do one example based on it. Show that the function fx is equal to x square is differentiable at x equal to 1. Now, we have to check the differentiability at 1. So, given fx is equal to x square. Now, left hand derivative formula is fc minus h minus fc upon minus h and limit h approaches to 0. Here we are having a point 1. So this is the value of c. So left hand derivative is equal to limit h approaches to 0 f of 1 minus h. In place of c we put 1, that is the value of c, minus f1 upon minus h. Now f of minus 1 h you can calculate from the given function. In place of x, you will put 1 minus h. So here, f of 1 minus h is equal to 1 minus h square and second is f1. It means value of x is 1. So here 1 square like this upon minus h. Now, you can see that it is of the form a square minus b square. So, apply the identity here, a minus b and a plus b. So, we get 1 minus h plus 1. Secondly, 1 minus h minus 1. upon minus h, and limit is approaching to 0. Now, here you can see that minus 1 and plus 1, they are cancelled out. So, we are left with minus h here only. So, it is 1 plus 1, 2 minus h. Here it is minus h upon minus h. Now, these two terms will cancel out. Now, when you apply the limit h approaches to 0 in 2 minus h, it will become 2 minus 0. So, answer is 2. Now, let's check for the right hand derivative. Right hand derivative is equal to limit h approaches to 0, f of 1 plus h minus f1 upon h. Formula written. Now, value of c is 1, and in place of x it is 1 plus h. So, when you put the value in the given function, here x, so it will become 1 plus h square minus 1 square upon h. Now, again a square minus p square, same identity that I have used in the left hand derivative also. So, 1 plus h plus 1 into 1 plus h minus 1. Again 1 and minus 1, they will cancel each other. So, we are left with 1 plus 1, 2 plus h into h upon h. Again h and h will cancel out. So, remaining is 2 plus h. So, when you apply the limit, we will get 2 plus 0 is equal to 2. Now, you can see that left hand derivative and right hand derivative, both are equal and its value is 2. So, we can say that f is differentiable at x is equal to 1 and its derivative is equal to 2. Let's do one more example. Examine the differentiability of function f defined by fx is equal to x square into sine 1 upon x if x is not equal to 0. And secondly, fx is equal to 0 if x is 0. So, we have to check the continuity at x equal to 0. So, 0 is the value of c. Now, again here function is divided into two parts. So, for left hand derivative and right hand derivative, we will get the value from the first part. Here x is not equal to 0. This implies x is less than 0 or x is greater than 0. Both are having same function, that is x square into sine 1 upon x. Now, left hand derivative equal to limit h approaches to 0, f of 0 minus h. This is the value of c. So, minus f of 0 upon minus h. Now, apply the value in the function. So, 0 minus h means simply minus h. So, in place of x, you have to put minus h. Now, for less than 0, we are having x square sine 1 upon x. So, in place of x, we will put the value. We get minus h square sine of 1 upon minus h. And minus value of f0 will be, when x is equal to 0, its value is 0. So, we have written 0. Now, minus h square will be positive h square into sine of minus theta. Sine of minus theta is equal to minus sine theta because it is an odd function. So, we can written as minus sine of 1 by h upon minus h. Now, here minus and minus will cancel out. So, we are left with limit h approaches to 0, h sine 1 upon h. Now, when you apply the limit, as it is a bounded function, so we can't apply the limit here. Here we will apply the limit on h only. So, 0 into sine of 1 by h. It is a bounded function because value of sine theta lies between -1 and 1. So when you apply at 0 here, it will become infinity, which does not exist. So we can't apply the limit on sine 1 upon h. So here 0 into sine 1 upon h, answer is 0. Similarly, right hand derivative. Now for the right hand derivative, again formula is there, limit h approaches to 0, f0 plus h minus f0 upon h. Now 0 plus h means h only. So here x is greater than 0. So x square sine 1 upon x. We will use this function. So in place of x and x square and x, we will put h. So we get h square sine of 1 upon h minus 0. Then upon h, limit h approaches to 0. Here h square sine 1 upon h upon h. 1 h will cancel out. So we are left with h into sine 1 upon h. Same type of limit is there that we get in the left hand derivative. So here again when you apply, it will again 0 into sine of 1 by h. So answer is 0. Now again left hand derivative and right hand derivative. Both are having the same value. It means they are equal. Hence f is differentiable at x equal to 0. In this way, you can check whether the function is differentiable or not at the given point. Students, I hope you got the topic now and you are able to solve the sums related to the differentiability of the function at the given point. Rest we will continue our next class.